In this video and this playlist, I am going to discuss some very important problems from this excellent physics book, and that book is widely used by mostly students who are pursuing the IB courses. So this is the book, the very famous book by K A Tsokos. So I am going to solve some very interesting problems from this book. So first problem that I am considering is this problem number 53. So in this problem number 53, he is asking to calculate the tension in the string that is joining the two masses in the diagram. So here we have the diagram, and here we have two masses of 30 kg and 10 kg, and we have to find the tension in this string. So he is asking that if the position of the masses is interchanged, will the tension change? So first we consider this situation A. So I have pasted this question here. So I have pasted this question in this window, and in first part what he is asking, in first part he is asking to calculate the tension in the string. So here we have two masses, and this applied force is 60 Newton. So first what we have to do, according to the concepts of physics that you might have learned, first we put the arrows for the tension. So this is the arrow for the tension. So always remember to put two arrows away from the body. Whenever you draw the tension arrow, put the tension arrow away from the body, pointing towards each other. So what next we have to do? In order to find the tension here under this applied force, first of all we will calculate the combined acceleration of the system. In such situations you have to find the combined acceleration of the system first. So for that I will write, let A is the combined acceleration of the system, and the external applied force is 60 Newton. Force per unit mass of the system is 40 kg. This 30 kg and this 10 kg is 40 kg. So this is 40 kg, and the external applied force is 60 Newton. So 60 by 40. So this is 1.5 meter per second square. So that is the acceleration of the system, means both the blocks will move with this much acceleration. Now we have to find this tension in the string. For that I am going to draw the free body diagram for this 10 kilogram block. So this is the 10 kilogram block, and the force that is acting on this mass of 10 kilogram is T here, and this block is accelerating in this direction with acceleration that we have calculated, that is 1.5 meter per second square. Now using the Newton's second law, the force that is acting on this 10 kilogram mass is T, mass 10 kilogram into acceleration, that is 1.5. So the force that is acting on this 10 kilogram block in the form of tension is 15 Newton. So A part we have calculated. Now what he is saying in part B, that if the position of the masses is interchanged, will the tension change? Let's see what happens. So this is the 10 kilogram block. This is the string with which these two blocks are joined. That is the 30 kilogram block. Now the external force is on this side. Clear? So that he is saying that if the position of the mass is interchanged, means this force is to be applied on this 10 kilogram block, or you can place this 10 kilogram block here, 30 here, and the force is to be applied on the 10 kilogram block, this force of 60 Newton. So I have just shown it this way. Now let the tension is T dash. In the same manner we will find the common acceleration, and that is again the same, that is 1.5 meter per second square, because the mass of the system has not changed. The external applied force is also same, so acceleration remains same. Now in order to find this T dash, I will consider the free body of this part, so that is 30 kg, that is moving with an acceleration of 1.5 meter per second square, and the only force acting on this mass is T dash. So using Newton's second law, T dash is mass, this mass into acceleration of this mass, that is 1.5 meter per second square. So if you multiply it, you will get 45 Newton. So from here we can say that when the position of the mass is interchanged, the tension will also change, and the new tension here is 45 Newton.